Hey, Math 20-2s. Today we're going to look at Lesson 4, Reasoning with Polygons. So a regular and irregular polygon. Definition of a polygon is a closed plane figure with 3 or more sides. That's the definition of a polygon. When all its sides are equal and all its angles are equal, it's called a regular polygon. A polygon which is not regular is called an irregular polygon. Polygons have special names according to the number of sides. Pentagons are 5-sided, hexagons are 6-sided. Stop signs, which are octagons, are 8-sided. Regular polygons can be constructed inside a circle as shown. All right, so these regular polygons are inscribed in the circle. All right, that means they've got their vertices on the outside of the circle. Joining each of these vertices, or the vertex, to the center results in a number of isosceles triangles. Right? That's the radius of the circle. That's the radius. They're the same length. This is the radius. All those are the same length. They're all radii of the circle. With that in mind, complete the table below to determine the measure of the interior angle of each polygon and the sum of the measures of the interior angles of each polygon. Let's look at that first diagram, the triangle. All right, looking at the triangle. Obviously, the triangle has 3 sides. The measure of the central angle, obviously, is 360 degrees divided by 3 because we've got 3 different triangles there. So this blue angle right here would be 120 degrees. Right? 360 divided by 3 is 120. Now it says measure of the base angle of the isosceles triangle. Here's the isosceles triangle, one of them that they're talking about. If I know this blue angle here is 120, then I can figure out these 2 equal angles. Isosceles triangle would have these 2 angles being equal. So we know the sum of the 3 angles is 180 minus that central angle of 120 and divided by 2 because we've got 2 equal angles here and you get 30 degrees. So each of these angles is 30 degrees. So you could write that in this diagram if you'd like. The base angle of each isosceles triangle is 30 degrees. And that's true for all these. They're all isosceles triangles. These are all 30. Every angle in there is 30. Measure of the interior angle of the polygon then. Well, I've got 2 30s, makes it 60. 2 30s here makes it 60. 2 30s there makes the interior angle of the polygon 60 degrees. And like I said, we now have 3 sets of 60 degrees. So the sum of the angles, interior angles, the sum of the interior angles of the triangle are 3 times 60, or 180 degrees. If you use that reasoning, we can figure out the measure of the interior angle of a 4-sided figure and the sum of all the measured interior angles. Now we're going to go to a square, which is 4-sided. So same idea, right? Connect the center to the vertices, and we make isosceles triangles of that because these are still radii. All right, so we've got now 1, 2, 3, 4 sides. We've got 4 isosceles triangles. Again, the central angle is always 360 degrees because it's around a circle. So central angle is 360, but now I've got 1, 2, 3, 4 triangles. So I divide 360 by 4. I come up with 90 degrees. So each angle here is 90 degrees. What is the base angle of each of these isosceles triangles then? Well, we do the same thing. We know the sum of the angles in the triangle is 180 minus the central angle, so 180 minus 90 is 90, and divided by 2 because these 2 angles are equal and they come up to be 45 degrees. Now, if every base angle in the isosceles triangle is 45, here's another 45-degree angle, here's another 45, another 45, and 45, another 45, another 45. So every interior angle of the square turns out to be 45 plus 45, or 2 45s, which is 90. And I've got 4 sets of 90 in the square. 1, 2, 3, 4. 4 90s is 360. So the sum of the interior angles of a 4-sided figure is 360. Well, let's do the same thing for a pentagon. So a pentagon has 5 sides. The measure of the central angle is 360 degrees. You divide that now by 5 because if you draw the 5 triangles from the center. They're all isosceles. These are all still radii. So 360 divided by 5 gives us one central angle, right? 360 divided by 5 gives us one central angle of 72 degrees. Now, how do I figure out the base angle of these isosceles triangles? Well, I go 180 minus 72, and then these two have to be the same, right? That's an isosceles triangle. Those angles must be equal. So like we did the last two examples, 180, subtract the central angle of 72, and then divide it by 2 to figure out the base angle of the isosceles triangle. All right, so 180 minus 72 is 108. 108 divided by 2 is 54 degrees. So every isosceles triangle here has equal angles of 54 and a central angle of 72. Well, this angle is also 54, so the interior angle, measure of one interior angle of the polygon is 54 plus 54, or 2 times 54, which is 108 degrees. And how many sets of 108 do we have? Well, there's one interior angle of 108 degrees, 2, 3, 4, 5 interior angles of 108 degrees. So we're going to go 5 times that interior angle of 108 degrees. So the sum of all the interior angles of a 5-sided figure is 540 degrees. Now we can do this for every single shape, but we see a pattern happening, so let's just follow through this pattern. So a nonagon is a 9-sided figure. Figure out the central angle, 360 degrees divided by 9 gives us the central angle of 40 degrees. We want to figure out the base angle of our isosceles triangle now, so 180 degrees minus that central angle of 40 degrees, and divide that by 2. So 180 minus 40 is 140 divided by 2, means each isosceles triangle has 2 equal angles of 70 degrees. That means the measure of one interior angle of our 9-sided figure is 2 times 70 degrees, or 140 degrees. And the sum of all the angles in a 9-sided figure would be 9. Sum of all the interior angles would be 9 times 140. We've got 9 interior angles. The measure of each interior angle is 140. 9 times 140 is 1,260 degrees. So I would like you to do a 12-sided figure. Pause the recording, do the 12-sided figure, and then restart it, and we'll do the n-sided figure together. All right? Away you go, pause it, and do the dodecagon by yourself. So here's what you should have for the dodecagon. Central angle, 360 divided by 12 gives us each central angle 30 degrees. 180 minus the 30, divide that by 2, means every isosceles triangle has 2 equal angles of 75 degrees in it. Therefore, one interior angle of a 12-sided figure would be 150 degrees. We've got 12 interior angles, all at 150, so the sum of those is 1,800 degrees. Let's do the n-sided figure together. So you take the central angle, 360 degrees, divided by n. Well, that's the best you can do. 360 divided by n, or you might want to write it as a fraction, 360 over n. All right. How do you find the measure of the equal angles in the isosceles triangle? Well, what have we done? We've went 180 degrees minus that central angle of 360 degrees divided by n. And then we divided that by 2 because there's 2 equal angles there. So if I simplify this, 180 divided by 2 is 90 degrees, minus 360 divided by 2 is 180 degrees over n. So that's the simplest form we could make that statement. Now we take each of our isosceles triangle angles that are equal and multiply that by 2. So 2 times the statement in the previous, 90 degrees minus 180 degrees over n. Well, if you multiply that by 2, we get back to that what we had in the first bracket there. 180 degrees minus 360 degrees over n. And then what did we do? we multiplied that by the number of sides we have. So we've got n sides. Multiply that by 180 degrees minus 360 degrees over n. If I expand that out then, n times 180 is 180 degrees times n, and n times negative 360 divided by n is just minus 360 degrees. All right, so you could make that statement. 180 degrees minus 360 degrees, 180 degrees times n minus 360 degrees. Or if you want to use factoring, you could factor out a common factor of 180, and you're left with n minus 2. So you're going to see this written probably more often than not as the sum of the interior angles of regular polygons. Let's go to the next page. Note, the work on the previous page shows that the sum of the measures of the interior angles of an n-sided regular polygon is 180 times n minus 2. Right, so we proved that with that chart. Irregular polygons, calculating the sum of the measures of the interior angles of an irregular polygon. So the diagram below shows some irregular polygons. Choosing a vertex and joining to other vertices, we can split the area of the polygons into non-overlapping triangles. All right. So the diagrams below show some irregular polygons. Choosing a vertex and joining to other vertices, we can split the area of the polygon into non-overlapping triangles. Well, one triangle, that's the best we can do. Four-sided figure, that's irregular. Well, we've got two non-overlapping triangles. A five-sided figure, that is irregular. We've got three non-overlapping triangles. A asks us to choose a vertex on each of the irregular polygons below, then join that vertex to other vertices to construct non-overlapping triangles. So it doesn't matter which vertice of this irregular polygon we choose. Let's say I choose this one. I want to draw that, connect that vertice to the other vertices through the center. So it's going to look like this, so we don't have any overlapping triangles. So how many non-overlapping triangles are in this shape? 1, 2, 3, 4, 5, 6. You got to do the same thing with the second shape here. Pause this and see how many non-overlapping triangles you come up with. So if you try this one, just the way I started, I chose this vertex, and I came up with 1, 2, 3, 4, 5, 6, 7, 8 non-overlapping triangles. You should get the same thing, doesn't matter which vertex you start from. Complete the table below to determine the sum of the measures of the interior angles of each irregular polygon that we did above. So the triangle up above, there are three sides, has one non-overlapping triangle. We know that the sum of the interior angles of a triangle is 180, and there is one overlapping triangle. So 180 times 1, all three-sided figures have a sum of 180 degrees. A quadrilateral. A four-sided figure has two non-overlapping triangles. Each triangle has a sum of 180 degrees of its interior angles. So 180 times 2 is 360. We look up here, and we didn't do a pentagon, we did a four-sided shape. So if I tried to do a pentagon, let's just draw that one real quick. Oh, this is a pentagon. 1, 2, 3, 4. Here's a five-sided shape. All right, so it's an irregular pentagon. How many non-overlapping triangles did it have? 1, 2, 3. So a pentagon has five sides. Whether it's regular or irregular, we're going to have three non-overlapping triangles. The sum of the measure of the interior angles is always 180 for one triangle. We've got three of them, so 180 times 3 is 540 degrees. Octagon has 8 sides. If you look at the 8-sided shape we drew up here, here's our 8-sided figure. 1, 2, 3, 4, 5, 6, 7, 8. In that 8-sided figure, we had 6 non-overlapping triangles. Each non-overlapping triangle has a measure of 180 degrees for the sum of the interior angles, and there were 6 of them. So 180 multiplied by 6 is 1080 degrees. All right. The decagon was a 10-sided one right beside that. We had 8 non-overlapping triangles. One triangle has a measure of 180 degrees for the interior angle sum. We've got 8 of those. 180 times 8 is 1440 degrees. A 100-sided polygon. Well, we see a pattern here. If I have a 100-sided polygon, how many non-overlapping triangles should I have? Looks like we're getting 2 less every time, so that should be 98. So the measure of one triangle, the measure of the interior angles of one triangle is 180. I've got 98 of those. So we can figure out the sum of the interior angles of that shape. 17,640 degrees. Let's look at the n-sided shape then. Well, looks like the pattern says we should subtract 2 from the number of sides to tell us the number of non-overlapping triangles. We should then multiply that by 180 degrees, and that should give us the sum of the interior angles. Well, that's the same formula we developed with the last one. So it doesn't matter if the shape is regular or irregular, the sum of the interior angles is always 180 degrees times n plus 2, where n is the number of sides in the shape. So the work on the previous page showed us the same thing. The measure of the interior angles, whether it's irregular or regular, is 180 times n minus 2. So we've got the following property. The sum of the interior angles of an n-sided polygon is 180 times n minus 2. Let's look at an extension of this property. Since there are n equal interior angles on a regular polygon, the measures of each angle should be 180 times n minus 2 divided by the number of sides. So this is the sum, and we divide that by the number of sides. We should get the measure of each interior angle, right? So that's that formula we had earlier, 180 times n divided by n just gives us 180, and 180 times negative 2 is a negative 360 divided by n. That's where we get the second part of this statement. So the interior angle of any n-sided regular polygon can be found using this formula. So this is for one angle. All right. One interior angle looks like that. The sum of all the interior angles is right here. The sum of every interior angle is 180 times n minus 2. The measure of one of those interior angles is 180 minus 360 divided by n. So an extension of this even further, since the exterior angle is supplementary to the interior angle, supplementary meaning they add to 180, the measure of the exterior angle should be 180 minus the interior angle. Makes sense, right? Here's our exterior angle, here's our interior angle. They have to add up to 180, they're supplementary. So to find the measure of the exterior angle, 180 degrees, that's the angle along a straight line. Subtract our interior angle, we just did that from up above, and we get 180 minus 180 is 0. 180 minus a negative. Minus this negative makes it positive 360 over n. All right. If you're not sure how that works, let's look at the math of that. Let's multiply through by that negative 1. So negative 1 times 180 is a minus 180. And negative 1 times a negative 360 over n is a positive 360 over n. So if we simplify that, 180 minus 180 is 0. We're just left with 360 degrees divided by n. That's where that comes from. So that's the third extension from this property. The exterior angle of an n-sided regular polygon is simply 360 degrees divided by the number of sides in that shape. It follows from the above property that the sum of the measures of the exterior angles of an n-sided regular polygon should be 360. Right? So if one exterior angle is 360 divided by n, and it's an n-sided shape, the sum of the measures of the exterior angles of all those would be 360 divided by n times the number of exterior angles there are, which is n. So 360 divided by n times n, well, those are going to reduce down to 1. And that's going to be 360 degrees. So that's where this property comes from. So let's do some examples based on these properties. Calculate in degrees the sum of the measures of the interior angles of a polygon with 9 sides. Sum of the measures of the interior angles. Sum of the interior angles would be 180 degrees times n minus 2. Well, n is 9 in this case. So 180 degrees multiplied by 7. 180 times 7 gives us 1260 degrees. Example 2, determine the number of sides. So now we're looking for the number of sides of a polygon whose interior angle sum equals 4140. So again, let's write it like that. Interior angle sum, I like that. The interior angle sum would equal 180 times n minus 2. Well, I know what the interior angle sum is. They tell us the sum of the interior angles is 4140. So that goes on the left side of this equation. 4140 degrees should equal 180 degrees times the number of sides in the polygon, subtract 2. So now we have to solve this equation. To solve this equation, I want to divide both sides of this equation by 180 degrees. So we can get rid of that 180. So 4140 divided by 180 is 23. So we get 23 is going to equal n minus 2. And now to solve for n, we're going to add 2 to both sides. 23 add 2 is 25. N minus 2 plus 2 is n. So there are 25 sides in the polygon who has an interior angle sum of 4140. Example 3. Determine the number of sides of a regular polygon, number of sides, of a regular polygon whose interior angle measures 170. So that's one interior angle has a measure of 170. So if we talk about one interior angle, you go back and look on your notes from the other page, the measure of one interior angle is 180 minus 360 over n. So we're told the measure of one interior angle is 170, so that's going to go on the left side of this equation. 170 equals 180 minus 360 divided by n. Now we have to solve this equation for n. So we could do a couple things here if you don't mind dealing with negatives. I'm still going to minus 180 from both sides. So 170 subtract 180 is a negative 10. And 180 minus 180 is 0, so I'm left with a minus 360 over n. Well, if negative 360 is divided by n, to get rid of that n, I want to multiply both sides by n now. So negative 10 times n is a negative 10n. And negative 360 divided by n times n, well, if you're dividing n by and multiplying it by n, they reduce down to 1. So negative 360 times 1 is negative 360. And then the last step in solve this equation for n, you divide both sides by negative 10. So negative 10n divided by negative 10 leaves us with just n. And negative 360 divided by negative 10 is a positive 36. So this shape has 36 sides if the measure of one interior angle is 170 degrees. Example 4. Determine the number of sides of a regular polygon. Again, we're still dealing with number of sides whose exterior angle, one exterior angle measures 60 degrees. So now an exterior angle, what's the measure of that? Well, if you go back and look on the other page, the measure of an exterior angle is 360 degrees divided by n being the number of sides in the polygon. We want to know how many sides are in the polygon when one exterior angle measures 60. So the exterior angle is 60 degrees. How many sides do we have in this polygon? Solve that equation for n. Well, if I write this as a fraction over 1 and I cross multiply, I get 1 times 360 equals 60 times n. And I now divide both sides by 60 to solve for n. So 360 divided by 60 is 6. And 60 divided by 60 is 1, so we're left with 1n. So in this case, a 6-sided polygon has an exterior angle measure of 60 degrees. Example 5. Determine the values of x and a in the diagrams below. So I see that we have a 1, 2, 3, 4, 5, 6-sided figure. So the interior angle sum of a 6-sided figure is 180 degrees times n minus 2. Well, there are 6 sides, so n becomes 6. So the interior angle sum of this shape is 180 times 4. So the interior angle sum is 720 degrees. So all these interior angles, if we add them all up, they're going to add up to 720 degrees. I can solve x by knowing that. All right. So let's write that statement. 720 degrees has to equal the sum of all these angles. So 110 add 120 add 125 add 115 add 130 and add x. So now we can solve this equation for x. So 720 would equal, you add up all those numbers and you come up with, what, 600 plus x. So now minus 600 from both sides of the equation. And we know what x is. 720 minus 600 is 120. 600 minus 600 is 0. 0 plus x is x. So the measure of x is 120 degrees. All right. Having seen that, I'd like you guys to try example 5, part B, and see what you come up with. So pause it, give it a try, and then we'll do it together. All right, this is a pretty tough example. In order to figure out the value of A, we need to know what this angle is right here in terms of A. So if I want to call it B or M or X, we're going to call it right now. Let's call it B for right now. How do I find the measure of angle B? Well, I know that B plus this angle have to add up to 180. So that angle is going to be 180 degrees, subtract A plus 20. So that angle is going to be 180 minus A minus 20. So 180 minus 20 is 160 minus A. So this angle right here has to have a measure of 160 degrees minus A. Now that I know all these angles in terms of A, I can figure out the value of A. So let's do the interior angle sum of this shape. Let's say 1, 2, 3, 4, 5-sided shape. So that's going to be 180 degrees times 5 minus 2, or 180 times 3, or 360 degrees. Oh, 540, sorry. 180 times 3 is 540 degrees. So I know that all these angles inside that 5-sided shape have to add up to 540 degrees. So 540 degrees has to be 3A add A plus 12 add 3A minus 40 add 2A add B, which we just found out to be 160 minus A. All right, so I can now solve that equation for A. So let's add up all these things. 3A plus 1A is 4A, plus 3 more is 7, plus 2 more is 9, minus 1 gives me 8 A's. All right, so I've got 8 A's. And then I've got 12 minus 40 is a negative 28, plus 160 is a positive 132. So to solve this equation for A, I'm going to minus 132 from both sides of this equation. So 540 take away 132 is 408. That equals 8A. We now divide both sides by 8. So 408 divided by 8, is 51. 8a divided by 8 is a. So you find out that a is 51. All right. So now we get into a little bit of algebra, solving equations for variables. All right. You guys got questions 1 through 10. You have your self-assessment to check those out. Away you go.